I'm going to go ahead and I'm going to start with what are some of the standards, what are some of the things that people use to build APIs, some pros and cons, go through some real-world scenarios in the 4 years that I've been integrating pretty much APIs nonstop, and some of the horror stories that I've found, what you can do to kind of help overcome problems that you're going to encounter when you're integrating and implementing APIs, and then what you can do in order to build better APIs, and some steps that you can take there. But first, I want to start off with APIs are everywhere. So this is just a map, a word map from Programmable Web that kind of shows you what types of APIs there are, the biggest three being mapping, search, and social. Some of these APIs are simple, and some of them are extremely complex. The stories I have today are going to talk and focus mostly on the complex APIs, but you can it can relate to simple integrations as well. So as I said, APIs are complex. For me, even more so because I actually work in the insurance industry. So talking about insurance, home and auto insurance, in order to insure your home, carriers need to know over 100 attributes about your property and at least 10 different attributes about each driver and each vehicle in order to determine your risk profile. So they have an XML standard called the Accord standard, and the XSD schema itself is 2 megabytes in size without documentation. It's 37,338 lines long. The transactions that we have to send these carriers are several hundred lines long in and of themselves and over 8 levels deep. And to top it all off, they have duplicative elements as well, such as a driver's license aggregate and a license aggregate that have the same fields inside of them. So verbose APIs, large messages, duplicative elements, and to top it all off, the standard actually has what they call an extensions service that provides the ability to tailor the standard Accord specification to the unique requirements of a service provider. What that means, in short, is it's not really a standard because you can do whatever you want. So it's an XML standard. How would you generally, as a service provider, build an implementation around this? Well, these are insurance companies. They tend to use SOAP, which stands for Simple Object Access Protocol. Simple is a bit of a misnomer. This is a Hello World web service, and this is the definition for that web service, for a SOAP service. So what do you need to know about SOAP? There's an action to call on the service, so get quotes for insurance, and it's very enterprisey. It has a large amount of overhead, with obviously XML being a very verbose language, and to top it all off, there's the web service specification set of headers that you can send along with it, such as WS Security, which provides enterprise-level security embedded into the SOAP header of every single request. One of the most popular ones is the X509 certificate, which is basically your SSL certificate if you go to a website and you see the little padlock. And you have to actually embed that in the header of every single request for authentication with some of these web services. They also have a WS addressing specification, which allows you to custom route your requests without relying on network-level transport. Some of the good things about it, though, is there's a lot of tooling built around it. You know, .NET web services, you can easily go in Visual Studio, say, I want to create a new web service. It spins up a whole bunch of code for you. You have templating, and you can just plug in your business logic, and boom, there's a web service for you. And if you're not working in .NET, say you have Java or C, there's Apache CFX and Access 2, which allows you in order to do pretty much the exact same thing. So WSDLs were actually created to handle the SOAP transport. And it's basically a definition or a description of your web service. There's 2 different specifications. There's 1.1, which is just SOAP mostly. You can do like post APIs and get APIs in there as well. And it came around in about 2001. In 2007, WSDL 2.0 came out, which kind of reworked the definitions and allows for a little bit better integration with RESTful services as well. But basically, the way it works is you have your types, which is what are the properties and attributes that I need in order to be able to call this service. So first name, middle name, last name would all be types of string. Middle name may or may not be required depending on the service. And you define all of that in this document. Then you have your messages, which is, here's the message I want to send. Then you have port types, which basically says, here's the operation being get quotes or get user or whatever that may be, that has both your input schema and your output schema that lets you know this is exactly what I need to send them, this is exactly what I'm going to get back. Continuing on, you then need to have bindings in order to bind those ports to a service that defines what the endpoint is. So, as I said before, simple is a little bit of a misnomer there. The benefits, though, is WSDLs are machine readable. They're not very human readable, but they're machine readable. As I said before, with all of the automated tooling, you can actually point a generator client in almost any programming language to a WSDL, and it'll automatically generate a lot of your client code, your services, models, and letting you know what you need to populate. It's fully documented right there inside. You know exactly what types are required, and you don't have to really worry about anything there. And as I said, has built-in language support. But some people don't necessarily do it right. The way that you're supposed to be able to read a WSDL is by going to the endpoint, and you can put a little question mark WSDL at the end there. I try and go to this web service that I'm integrating, and it says it's unable to generate the WSDL for this service because set use original WSDL is false. When I reach out to the partner and ask them, how can I access your WSDL? They said, oh, it's okay, it's in our documentation, which is in an Excel workbook. That's not the way to do it. Another fun fact is it's very easy to mess up. There's automated tooling around it, but it's extremely easy to do this wrong. So this is a WSDL that actually did get returned and is not in an Excel document. But how they define their types is, and it's a little hard to read on here, is they have an element for transaction, which has a subsequence of elements, one of them being a chord string, which is a type of string. So when you generate the request and try and send that to the partner, this is kind of what it looks like. You have your SOAP envelope, your body, you're sending a transaction, and now you have your accord string, which is, as I mentioned before, that 37,000 line long XSD that tells you how you're supposed to format your XML. So on the flip side, you have REST that's come out now as well, which stands for Representational State Transfer. In one line, this is kind of what a REST request would look like. You have your HTTP verb, your host, and your resource, and then finally your identifier for which resource that you're trying to get. But it's not always that simple. Extended version is, it was actually defined in Roy Fielding's PhD dissertation. Just by show of hands, how many people have actually read any PhD dissertation before? Not very many. So the way that it's defined in this dissertation, too long, didn't read, there's 6 architectural constraints to REST. The first being client-server. What that basically means is the client doesn't care about how the data is stored, and the server doesn't care about the client's user interface. It has to be stateless, which means that anything you need to do in order for that request to happen needs to be sent along with the request. So no setting cookies, the server doesn't know anything about the client, and any authentication or whatever else needs to be sent along with the request. It's cacheable, meaning that the clients can actually cache and store locally the responses that the server sends back, so long as the server tells the client that they're able to do so. Layered systems, meaning a client doesn't care what it's connected to. It can be either a proxy, a load balancer, whatever else. On the server side, you can layer it. The client doesn't necessarily care what it's talking to. It just knows I'm sending a request, I'm going to get a response back somewhere. And then there's uniform interface. So uniform interface, there's a lot of subcomponents to this. As I mentioned, the resource structure before, it identifies resources through URIs. The manipulation of the resources actually is on the client side. So I get a resource object back. If I want to change a property on the user, I change that property on the user and go ahead and send it back to the server in order to update that resource. And it's self-descriptive messages as well, so you know everything that you need to know when you get that message back. And then the last constraint of the uniform interface is hypertext as the engine of application state. We'll talk about that on the next slide. The last and the only optional architectural constraint is code on demand, which is actually pretty cool. What this means is the server can send code back to the client to then execute and temporarily modify that client's state. So you can send back maybe some JavaScript code to run on a website or so on and so forth. So, but again, it is an optional constraint for REST. So hypertext is kind of where REST falls a little bit flat. It's very academic in its definition. But basically what it means is the only URI that your client needs to know is the root of your service. So I need to know api.yourwebsite.com, and from that, I can actually discover any other resource that your service provides. Almost like a standard website with links that you can click through in order to generate the subsequent requests. What that means, though, is standard JSON, YAML, and XML isn't truly supported in REST just because it has no way in the language itself in order to define the linking mechanism. Now, there are new standards that are coming out like JSON-LD and a couple of standards for XML that do define this linking structure, but out of the box, the only structure that's supported are things like Atom, SVG, HTML, or XHTML, which doesn't really solve for the verbose issue. So the good and the bad around hypertext, the good is the API is self-documented. All I need to know is one endpoint, and if my client's written properly, I can actually discover and the user can interact with any other resource without having to read any documentation. The bad is it actually takes multiple requests and there's a lot of message format overhead. And when I say multiple requests, I mean you need one request in order to know what you can do, and then another request in order to actually do it. Proper clients can also auto-discover new features, so you don't have to version your APIs at all. But the client implementation is extremely difficult. So one thing that I skipped over around REST is the CRUD operations are performed using HTTP verbs. So what that means is you send a GET request over HTTP in order to read a resource. If you want to create a resource, you use POST. If you want to update a resource, you use the HTTP verb PUT. And if you need to delete a resource, you use the delete verb. So some of the problems that are out there in the wild with REST is they're bogus resources. Resources you can think of as nouns. You have your users, you have your tweets, you have your statuses, but so that's kind of different from SOAP, where SOAP are actions, SOAP are verbs, stuff to do, whereas in REST, it's nouns. But in the wild, you have some pretty bogus resources that are out there when people are trying to build REST services. For example, this one is using GET to the services resource, which isn't very descriptive, but it has an operation of update customer, and it's passing in the customer ID. So the way that you would do that would generally be to put customer ID and update that resource. Another thing is post customers, so the first resource is kind of correct, right? And you have your ID, so you know this is the customer that I'm going to be doing. But at the end here, you kind of have another method. It's a verb that says update. These are things that I've actually seen out in the wild. Put update customer, again, it's a verb, it's not a noun, it's not very descriptive. And it's also redundant because you're telling it that you want to update by using the put verb, but then you also have a resource named update customer. And this one hits a little bit close to home. I had to find some examples. Nobody's perfect. This is actually from my company's own internal code base where we have a resource named data. Another problem with REST in some implementations of REST is people don't generally use HTTP status codes correctly. So here is a simple example where using, again, this own internal system that I've used, I said, okay, we have a resource named data. What happens if I change that resource to data1? This is using curl on the command line. I'll walk you through it real quick. Basically, it's trying to connect to it. All right, it found it. It connected to it. And I'm issuing a GET request for API monitor data1.json. Here's what I get back. I get an HTTP 200. Okay, great. Message is received. And the response is JSON, error. The class API monitor controller data1 controller was not found. Which should have returned a 404, obviously. So I've talked a little bit about some of the headaches that you can run into, and I'm sure that many of you have when you're trying to integrate APIs. So let's talk a little bit now about what we can do to overcome those obstacles as we run into them. First thing that we need to be able to do, obviously, is read between the lines. Can you connect to the service? Don't sit there and spin your wheels saying, it looks right, what's going on, I'm not getting a response back. You know, if there's no errors, and for example, one of the issues that I had was trying to send these requests to this service. I reached out to them saying, hey, I'm not getting any responses back. They say, oh, well, we're not getting anything on our end either. And they ended up spinning their wheels for a couple of hours before I finally said, I sent you the IP addresses to whitelist in your firewall. Did you do that? No, they didn't. So another thing to look at is, how does this API handle errors? I just talked to you about properly using status codes, and there's many APIs out there that don't. So some APIs, you just can't rely on the status codes. Sometimes they just send it back in an inline message. Next thing is there an error message? Though error message can be a hindrance as well as a help. Going back to insurance, I was actually having an issue last week where I was sending a request that I thought looked pretty valid, and I was getting this really crazy response back that ended up being a subsystem that this API was reaching out to after I sent their request. And this subsystem was blowing up and it was dying. So the error message that I got back was this nice big long Java exception detailing the entire subsystem and what was going wrong, including line numbers inside of their code. What really ended up happening is I was formatting a date incorrectly. So if there's an error message, read it, look into it, see if there's something that you can do or if it makes sense. But if you're unable to validate it on your end and see that, oh, this error message says date is formatted incorrectly, you should look at the documentation and format that date correctly. But other times, you're going to get error messages back that don't make any sense whatsoever. So the best thing to do there is to seek help and don't sit in an endless loop. Whether that help is you're integrating a public API that someone might have done before, so look at GitHub and see if there's something you can look at there. Stack Overflow, or even peers at work might have done something similar before. But in a lot of cases, it's going to come down to, especially if you're paying for an API, so this next slide isn't really going to pertain to using a public API like Twitter, but you have to reach out to the production support team sometimes. And as developers, we all hate that. Talking to people is annoying. So when you seek outside help, how do you get the responses that you're looking for? First, you have to describe the issue in detail. Don't leave out any messages that you're seeing or anything that you've already done in order to try and resolve that issue. Another thing is ask questions that prompt short responses. So say, hey, I'm trying to connect to your API. I'm getting this error message. This error message has absolutely nothing to do with my system, and I have no idea what's going on. You don't want to say, can you tell me what's going on? Because then they can go down any path. What you want to be able to say is, hey, I'm trying to connect to your API. I'm having some issues with this error message. I've tried to go ahead and read through the message and resolve on my end, but it looks like there's a problem in a subsystem using this. Have you seen this before? Right? And that'll at least start a conversation. Frequently follow up, because if you don't, you're not going to get the answer that you're looking for. And finally, even with seeking outside help, sometimes people have no idea what they're talking about. The XML inside of XML example that I had before was an issue because the actual XML that was inside of that XML was a SOAP request inside of a SOAP request. So their documentation included a sample request that I just then tried to send directly to them using curl, just to make sure that the API was working correctly. And I was getting errors back from their system, so I sent them an email and I said, hey, it looks like I'm unable to connect to this API. I'm getting this error message back saying that the request is not valid. And what they responded was, well, are you using a Mac in order to send the request? If so, you might need to use Java to generate your XML. Thanks. Test first, code second. So I was talking about using curl earlier, and one of my earlier examples had that. When you're overcoming obstacles, it's obvious that there's potentially issues with their API, especially if it's not used globally. If you try and build a client to that API first without initially testing the API and getting a feel for the structure and how it's going to work, then you have no idea whether the issue is with your client implementation or with their API. So get a feel for the API before starting on any integration effort. As I mentioned, ping, traceroute, and curl can help solve a lot of those problems. The connectivity problems with them not having their firewall opened ended up getting resolved because I ran a traceroute on their endpoint, and I noticed that, hey, the packet was dropping right before it got to their firewall, and wasn't generating a response. They just killed it. Ping, just to see if you could, easier way of checking connectivity between endpoint and endpoint. And then curl, if you have a sample request, I'd highly recommend, if you have a Mac and you're not on a Windows-based, to take a look at curl and some of the commands there, because it's really easy to just send a quick request over and get that done. If you're not as comfortable with the command line, there are some other clients out there as well, and I'm going to go ahead and plug some of them. So one of my favorites is Postman, which is a REST client. It's actually a Chrome extension, which allows you to test APIs without, again, having to write any client code. And the other that I'm going to talk about is SoapUI. So when you do have these enterprise-y clients that actually have WSDLs and you have to try and parse and read through that, you can use SoapUI in order to send some example requests as well. So with Postman, kind of the way that it's set up, it's again a Chrome extension. And over on the left here, you have your collections. So this is an API that I actually built out. And I can post to get an auto quote. I can also put in order to update some of the information and update that quote, and then get the results of a specific quote as well. So the way that Postman is laid out is you have up at the top there your URL and your HTTP verb. It has built-in support for authentication, like basic authentication, digest, OAuth 1 and OAuth 2. So if your APIs require some special authentication, they'll make it easy in order to add those as well. You can modify the headers that you're going to be sending with the request, and you can also add additional URL parameters to it. They also, in the middle section here, have different types of data that you can send. So I'm sending just raw data because it's XML. Form data on the left will just give you a way to set key vals. And XWW form URL encoded, again, if you just have a URL string that you want to put in there instead of manually typing out the form, you can do it that way. You can also send binary data with it. Hitting preview here, besides send, or besides save, will actually let you see what that request is going to look like with the HTTP headers and the actual HTTP request, and will give you the curl command to send that request if you want to do it from the command line for a later purpose. When you hit send, it'll go ahead, it'll call the API. You can see status is beside the headers there. It's a 202 accepted status for this request. And then you have the list of headers as well as the body that sends back. So it makes it extremely simple in order to start testing APIs. If it's a JSON API, XML API, just take a sample request, throw it in there, play with it, see what data you need, what data you want, and how to connect. SoapUI is for, as I said, the other more enterprisey applications, but basically what it'll let you do is it'll let you take a WSDL, whether you have it locally or whether you have it on the web, and when you create a new SOAP project down here at the bottom, you can call it whatever you want, tell it what your initial WSDL is, and it'll actually go ahead and it'll build out all of your services and sample requests for you. So what I have opened up right here is a sample request which has the XML structure. It lets me know which elements are optional, and I can literally just go through here and start filling in these XML nodes and hit send in order to send a sample SOAP request. So there are tools out there that'll definitely make it easier for you when you're trying to integrate APIs. So aspirations. This point of my talk is what can we do in order to create better APIs or do it correctly, and that's actually not what I'm going to talk about. I'm going to talk about defining the constraints of your API, because I don't care about perfect APIs. I just want something that works. So defining the constraints, know what your API is going to do. Before you write a single line of code, know what resources if you're using REST, know what actions if you want to use something else that your API is going to have, and hammer all of that out before you even write a single line of code. And then design your interface around knowing what you want your API to do. So what resources am I going to have for REST, what actions, and design that interface. And finally, model it out. Create machine-readable descriptions. So I talked about WSDLs, and yes, I know they're a pain in the butt, but having them actually helps, especially when you're going to be using a SOAP service. And WSDLs actually have some support for REST services as well. There's a lot of RESTful modeling languages around too, which are extremely helpful. So we've got RAML, which is RESTful API modeling language, API Blueprint, which is from API-Airy, Swagger, which is from WordNik, and IODocs from Mashery. What these allow you to do is they allow you to model out what requests, what resources you're going to have, and from this, the tooling isn't quite there yet for these RESTful services, but you can generate server code, generate client code for these RESTful API definitions. And even better, especially with Swagger and IODocs, and well, most of these, RAML as well, you can actually generate executable documentation. So if you've ever seen a website where you go to the developers section and there's an API console, generally those APIs are defined with one of these modeling languages and run through a program in order to generate that API console, which lists out, here are all of the requests that there are. Here's a sample request, a sample response, or fill in this data and generate a response. and actually execute that API call on their documentation website, which means you don't need to use Postman because you're right there and you can test that API directly from their documentation, directly from their website. Secondly, you need to be able to make defendable decisions. Pick a standard and follow it is the most simple thing that I can say. I don't care whether you use SOAP or whether you use REST when I'm integrating APIs, but what I don't want to see is a SOAP API that doesn't have a whistle, or a SOAP API that doesn't have their types defined inside of a schema. Same thing with RESTful APIs. You know, there's a debate going on now about whether hypertext is good or bad or whatever. Most companies use practically RESTful APIs, which follow the first 4 constraints, just to make it easier for clients to implement. So another thing is you need to be able to seek input on design decisions. And I actually might be doing some of that here. So as I showed you in a slide before, the API that I built out in order to generate auto quotes, very enterprisey, carriers are slow. It takes 15 to 30 seconds in order to get a request back. So when I'm building this API that is kind of middleware in order to be able to send a single request, reach out to all these carriers and get all of their rates and return that to the user, I kind of came up with 2 options. One of them was, well, I can do it synchronously, but then it's going to take 15 to 30 seconds times however many carriers I have to request out, and nobody wants to wait that long. So I can use multi-curl in order to send all of the requests at once, but then it's still going to take as long as the longest API took. That's better than synchronously, though. The third option was to do what I kind of did, and I'm playing with now, where when you send a request, I'll validate that request, but I'll send you a 202 accepted response back, which is different than 200 because the way 202 is defined is, hey, I received your message, but I've still got to do some stuff on the back end before you can get the result. So it makes integration with that a little bit harder, right? Because now I've validated your message. I know that in all likelihood, you're going to get the information you want, but I still have to request all of this information from all of these people. So I'm throwing it on a message queue, which then has runners go pick it up and actually fetch the results, and I return a 202 with a location header of a queue that you can then go to see what's the status of this API call, right? So that creates 2 requests instead of just 1 request and you get your response back. But what it lets you do is submit the request on the back end after the user posts the information, and then actually display something to the user while you're waiting for the responses, like a loading bar with all of the carriers. And then you can use JavaScript in order to pull or even create a WebSocket to that response queue, and as results come back, you can start populating your UI with it. It creates a lot of additional work for the developer, but is it worth saving that 30 seconds or 45 seconds while the user's waiting for the response in order to get them on the page or not? And that's something that I don't know. When I talk to my peers, we decided to go the asynchronous route, but it's something that's still up in the air. So seek input on design decisions, and you're not going to know everything. If you have to do something out of predefined methods, have a good reason, and that's kind of out of predefined. You don't see very many RESTful APIs that return 202 responses. Has anyone ever seen a 202 in their life? Yeah. So I kind of have a good reason for doing that, and be able to defend that decision. Be able to say, this is why I'm doing it this way. And finally, know that there's no such thing as a beautiful API. You need to focus on functionality before you focus on getting it perfect or getting it right. And functional APIs are self-documenting. Logging is also required. When I say logging is required, I mean you need to know every request that you received and every response that you sent back. You can start simple. Plain text logging or sending it to syslog will still give you insights into your API that you wouldn't have without. And as your API starts gaining traction, you need to be able to have a way to monitor activity, which isn't possible unless you're logging in some way these requests and responses. Some things that you can log are error rates across each API call or resource, or the runtime on the server of how long is it taking me in order to actually generate this response. And consumer fingerprinting, meaning, is it just one person that's having this issue, or is it everybody, right? Some people are louder than others. And if you're not logging the results of your API, then generally those who are louder will get the most attention. But it might not be a big issue. It might just be some small edge case that, yes, you need to fix, but you don't need to light a fire and work 80 hours a week in order to do it. And then lastly, be proactive in reaching out if possible. So what do I mean by be proactive in reaching out? If you're actually logging the requests and the responses that you're sending back and the error messages that you're giving back to the customer, you would actually be able to tell the customer that they're having an issue and they might not even know it. So has anyone here heard of Rollbar? Rollbar is kind of an error logging system, and it works for multiple programming languages. But they have an API integration where if you have an error in your application, you can send it up there, and they'll aggregate it for you, and they'll notify you of errors. But what they do, and what I like, is if you send them a request up of the error that wasn't formatted correctly or something like that, next time you log into their system, a nice red banner shows up that says, hey, we saw that you sent a request that didn't get logged properly. You should look at this in order to fix it. It doesn't have to be as complicated as that. It could just be an automated email where you know that you have an API issue because you're tracking everything, and you just send an email out to all of your consumers saying, hey, we're having issues, we're working on it. Or if it's just a single consumer and you know what the error message is, and they might not be looking at the response messages that you're sending back to them, and it's happening 80% of the time, you can send them a quick email saying, hey, you're trying to access this, you're doing this incorrectly. Lastly, eat your own dog food. Write your own client library for your API. Whether it's in the programming language that you're using or other programming languages, it'll actually give you insights into the design decisions that you made as you're actually writing the client for your API. There's many times that I've actually written an API, designed it, and went and built the client and changed my design because it was really hard to implement on the client side. Consume your own API kind of goes hand in hand with writing your own client, but this gives you insight into your response format and the information that people actually want back. How hard is it to get to the information that people actually want to use? Test every aspect of your API in development. If you're actually consuming your own API in your internal applications, this becomes easy. But if you're just writing an API that's exposing data to other people and you're not consuming that same API in-house, you're accessing that data directly, it's extremely difficult in order to see whether or not it's actually successful. And have a unit test suite and continuous integration solution in place. If you make a change to the API, did it break something else? Or if I'm deploying this, automatically run my tests so I can't accidentally break something else. And don't release until you're satisfied after writing your own client library and start consuming it yourself.